Okay, we are still in module 5. This is part 3 of MLOps and automated workflow. As we talked in the other parts of the same module, module 5, we talked about design and development. And now we are talking still about the deployment. A, a very important part of the deployment is continuous integration, continuous delivery pipeline. So this pipeline, continuous integration and continuous delivery or deployment, most of the time they say, is coming, as we said in the previous modules also, it's coming from DevOps. It's an integral part of DevOps, of course, and it supports the automation for a great automation process, let's say. So what is it? Continuous integration, series of steps, of course. Continuous integration focus more on the plan and the code and building. And continuous delivery or deployment focus more on the deployment part of the whole process of the machine learning. So the CI is more toward the code and continuous deployment is more toward the code when the code is completed. So when the code is changing continuously, so we do the continuous integration. Each stage is automatically tested. And we do this, for example, with the help of Git or GitLab or GitHub. And it's easy to identify when there is some error in the compilation or in the code when there are some change in the code that cause the problem of the code when you compile. So it's good for also for root cause analysis. So you know where the bug or the fault is coming. Continuous delivery deployment is a kind of integration with continuous integration, let's say. It's a kind of closely matched and automatically going on, and it's more on the release of the software. Here in the machine learning, we are focusing more on the release of the model in itself. So the idea is to produce the model continuously and automatically when something changes. We will come back to this for the data. Now, if you have the model and you want to deploy it, it's a matter of a lot of decision to deploy it. It's not like simply you plug in and out. So there are different strategies, of course, but there are three main strategies, let's say. The first strategy is the silly strategy, which is a basic deployment. You just replace it. You have a model now working on your system. You just put the new model when you train it with the new data and you think that everything is okay. You just on and off. You remove, archive the old model, you put the new model in production. So this is a kind of basic deployment. There is another kind of deployment, which is the shadow mode. We say the shadow deployment, which means that we have the old one is working. We have the new one. We put it in parallel. It's not in production now. Still, the user is using the old one, but you have the new one. The data is coming to this one also, and you are monitoring. And when you think that everything is okay, if I put this in production as compared to the old one, and everything is okay, the system is working fine, then it's time to change. The other kind of deployment is that you have a canary mode. Canary mode or canary deployment means that you have the new model, you put a small part of the model in production and see how it works. And if something happened, you immediately roll back to the old model. If not, you slowly go to the deployment with the old one, with the new one, and when everything is okay, slowly we put the production on the new one. So it's like, for example, if you have 100,000 of users um, in production and getting decision from this, from your model, you put like thousand of users on this model, on the new one, and see if it is working. If it is working fine, you put another 1,000 or 10,000 more, and slowly you put these users on the model, not immediately you put 100 users. So you see that there are pros and cons here. With the basic model, with the basic deployment, it's straightforward, it's easy, but there is high risk, of course. With the shadow mode, it's easy to implement, no risk, and but you need a lot of resources. So if you have computation for one model, now you need computation for two models, computation power. The canary deployment is a bit hard to implement, but there's a small risk. If doesn't work, there's a small risk like for example, only 1,000 user will fail or will feel it and not the rest of the users, for example. We have the monitoring. Also, part of the deployment is the monitoring and retraining. Monitoring, what we are monitor, actually, we monitor a lot of things. And if you go to the standard, let's say if you go to the standard cloud, there are different levels of monitoring and you monitor basically everything. Why we monitor? As we said in the other modules also, we want to make sure that everything is okay. And if we discover something later on, we come back to the data that we have, and we basically see the root cause of that problem. If you are live monitoring, so you get alarm and so on. So there are different levels of monitoring. For example, you have the statistical monitoring, which focus on the input and output data and takes the statistics and the customer, for example, and so on. So this is a kind of monitoring, that you monitor the input and output and take statistics from both sides. Computational monitoring, you focus on the computation usage, the resource usage, for example, the usage of memory or CPU, or number of incoming requests, number of predictions, downtime in the server, and so on. So you can see that we can log all the information from the whole process. You have the API, you have the machine learning model, you have the data pipeline, and so on. A robust monitoring system detects issues, also provide detailed information about what happened. How to do this? Most of the systems are just recording the logs when the system is working. Another thing is that when you have a data pipeline, and when you have a data pipeline, you need to monitor also. This is a difficult issue when you have the data pipeline and you have data ingestion. The data is coming from different sources. You can see that you have to validate. For example, here you have there are three sources of data, for example, in this graph here, table 1, table 2, table 3. So you have to validate each table individually, and you have to validate when you ingest and combine these two tables together. And then you have to validate the whole process and so on. So it's a kind of complicated when you want to monitor the whole pipeline of the data. How to do this monitoring? Sometimes, most of the time, we are focusing on the ground truth and feedback loop. The ground truth means that the actual or correct results that you are expecting. This is very important for the model evaluation. Also, you should always have some ground truth to validate against it. How to do this? Most of the time, we have feedback loop also, which means that using ground truth to improve the model with the feedback loop. We can identify with this when it happens and why it happened. So another thing we have to monitor, which is very, very important nowadays, is the data and the drift of the data. Most probably, we focus on input and output. Input means that input data, that is the table or the kind of the data that is streaming and coming to you. And the target, which is the output, for example, label of the data. Is it like, is it the classification? This is this user churn or not, or whatever the target is in the machine learning. Data drift means that there is a change in the input distribution. So the data is changing over time, different customer demographically change, the customer change its address or whatever. But the concept drift is the change of the relation between the input and output. This customer was churning before, is not churning again, for example. The behavior of the system. The customer was sleeping during night, but he has changed his work, and now he's sleeping during daytime. So there is a relationship change here, and based on that, the model is changing. So the concept drift has a very great impact on the model and performance, and the performance is degrading when there is the concept drift. We talked about this before. Also, so if you figure out that the model is changed and the performance is degrading, it's time now to retrain. But it's also about how often you retrain. It depends on several things. For example, the business environment, how the data is changing, how frequent the data is changing, and how frequent the model degrade of course. The cost, how much it costs when you do the retraining. So, and how often you want to retrain. And also the business requirements. Sometimes 99% accuracy is needed, but also the company or the business is okay with even 97% of accuracy. So if the accuracy comes down from 99 to 97, you don't need to retrain. So it depends about the requirement of the business, the use case, and so on. So if retraining is needed now, so how to retrain, of course. So retraining means that you have a new data, you completely neglect the old data, you retrain You train a new model on the new data and you just deploy it, as we said before, with the deployment phases, with the deployment methods. Or uh, you combine the old data, part of the old data and the new data, and you retrain a new model or the old model. You have it. Automatic retrained, sometimes, most of the time, we have triggers and we have monitoring, and during the monitoring, we set some triggers. For example, we say if the accuracy level came down to 95%, for example, you do the retraining and then you go through the CI/CD pipeline. So now it's time to talk about maturity level of MLOps. So maturity level means that the degree of automation, how automated, which is the degree of automation here? How much you automate the system? So for example, there are 3 levels of automation. However, the higher level doesn't mean that it is good or bad. It depends on the use case requirement. Sometimes you just go with the first level, let's say. So we have level 1, level 2, level 3. Level 1 basically means that there's no automation at all. And it's a classical thing. You develop the model, you do everything offline, and you send it to the deployment guys, and you say, you deploy this for me. There is no collaboration, there is nothing. Also, there is no monitoring. Everything is just like data science classical thing. However, there's level 2. This is level 1, for example. This is manual process, lack of collaboration. You just send the model over a flash memory or an internal channel or over email, and you say, just deploy this model for me. You don't track the model, the data, the monitoring, and so on. This is there's high risk for this, and the whole process is manual. However, there's level 2. Level 2 means that the pipeline is automated. There is an automated pipeline. However, still the deployment, you go for the automated pipeline. Everything is data processing and everything is automated until the model is created. When you have the model, then you send the model to the deployment guys, as we said before, by email or by flash memory and so on. So, but you track the system, but there is some tracking of the system and you get the data, but it's not connected. These two things are not connected. The development and the deployment are not connected together. But you have limited monitoring also. Fully automated, which is level 3, which means that fully continuous integration, continuous deployment, and these levels, these steps are connected to each other, starting from the data until the deployment. Everything is connected, everything is automated, and until you retrain, monitoring, everything is connected.